Welcome back, guys, to Mathematical Mindset. Right here we have this nice Math Olympiad algebra problem, and we have to solve for the value of x. So guys, the first thing you want to do is to simply rearrange this equation. So rearranging this equation, we have this to be 8 raised to the power of x is equal to 6x. So divide both sides by 8 raised to the power of x. So this is going to cancel out this. So we have 1 is equal to 6x over 8 raised to the power of x. So we want to simply apply this property of exponents that says that if we have 1 over a raised to the power of n, this is equal to a raised to the power of negative n. So this is it right here. So applying this property, this becomes 1 is equal to 6x multiply 8 raised to the power of negative x. So we have this right here. So we want to divide both sides by 6. So this is going to cancel out this. So we have 1 over 6 is equal to x multiply 8 raised to the power of minus x. So rearranging this equation, this becomes x multiply 8 raised to the power of negative x, which is equal to 1 over 6. So right here, we want to simply apply the Lambert-W function to solve this right here. So applying the Lambert-W function that says that w multiply a e raised to the power of a is equal to a. So we want to simply apply this function right here. So in order for us to apply this, we want to simply multiply the expression by negative 1. So multiply this equation, we have negative 1 multiply x multiply 8 to the power of negative x is equals to negative 1 multiply 1 over 6. Okay, so we have this to be negative x multiply 8 to the power of negative x, and this is equal to minus 1 over 6. So we want to simply apply this property. Now the reason why we are applying this property is, if you take a look at the Lambert-W function, we have a multiply e raised to the power of a. So we want to simply apply this property to make sure that we can change 8 to be e right here. So applying this property that simply says that if we have e raised to the power of ln a, we have this to be equal to a. So if we apply this property here, this implies that e raised to the power of n of 8, this is equal to 8. So that simply means e raised to the power of L of n of a is the same thing as 8. So this equation is going to become minus x into, we have this to be e raised to the power of L of n of 8 raised to the power of negative x, and this is equals to minus 1 over 6. So from the property of exponents, we have that a raised to the power of m or raised to the power of n, this is equating as a raised to the power of m multiply m. So from here, this implies that minus x multiply e raised to the power of n of n, so we have this to be minus 8x is equals to minus 1 over 6. So this is minus x e raised to the power of minus x ln of 8 is equal to minus 1 over 6. So we have this right here. So the next thing we want to do is to multiply both sides by L of n of 8. Alright, so multiplying this, we have L of n of 8 multiply negative x raised to the power e raised to the power of minus x L of n of 8 is equal to minus 1 over 6 multiply L of n of 8. So from here, we have this to be minus x L of n of 8 and multiply e raised to the power of negative x L of n of 8 is equal to minus 1 over 6 L of n of 8. So we have this right here. So we have been able to satisfy the right hand side of the equation. So for the right hand side of the equation, we want to simply apply the Lambert-W function one more time to the right hand side of this equation. So applying the Lambert-W function, we have this to be, and the Lambert-W function is w multiply a e raised to the power of a, and this is equal to a. So from the right hand side of the equation, we want to simply note that we can easily write minus 1 over 6 to be equal to minus 1 over 2 multiply 1 over 3. Hence, the right hand side of the equation becomes minus 1 over 2 multiply 1 over 3 L of n of 8. But from the logarithmic property, we have that b L of n of a, this is equals to L of n of a raised to the power of b. So applying this property, this becomes minus 1 over 2 multiply L of n of 8 raised to the power of 1 over 3. Okay, but we know that 8, if we express it in terms of 2, this is 2 raised to the power of 3. So this is equals to minus 1 over 2 multiply L of n. Now in place of it, we are going to put 2 raised to the power of 3 into 1 over 3 right here. So from here, we have this to be minus 1 over 2 L of n. So 3 is going to cancel out 3, so we have this to be 2. So from here, we can express this to be 1 over 2 multiply negative 1 multiply L of n of 2. So we want to simply apply the logarithmic property that says if we have b L of n of a, this is equals to L of n of a raised to the power of b. So this is equal to 1 over 2 multiply L of n of 2 raised to the power of negative 1. Alright, but we know that if we have a raised to the power of negative n, this is equals to 1 over a raised to the power of n. So applying this becomes 1 over 2 multiply L of n of 1 over 2. So we have this right here for the right hand side of the equation. So right here, we want to simply impute this value into the right hand side of this equation. So hence, we have that minus x multiply n of 8 multiply e raised to the power of minus xn or ln of 8. This is equal to 1 over 2 multiply ln of 1 over 2. So we have this right here. So from this expression, we can get the two values of x. So for us to be able to get the first value of x, all we have to do right here is to apply the Lambert W function that says w multiply a e raised to the power of a, and this is equal to a. So from this property, we know that e raised to the power of ln of a is equals to a, right? So we want to simply apply this to the right hand side of this equation. So e raised to the power of ln of 1 over 2 is equals to 1 over 2. So in place of 1 over 2, we want to put e raised to the power of ln of 1 over 2. Now we are doing this to make sure that the right hand side of the equation corresponds with the Lambert W function. So this implies that minus x ln of 8 multiply e raised to the power of minus x ln of 8. This is equal to, now in place of 1 over 2, we are going to put e raised to the power of ln 1 over 2 into ln of 1 over 2. So this becomes the new equation, okay? So from this part right here, all we have to do is to apply the Lambert W function, right? So we have minus x ln of 8 multiply e raised to the power of minus x ln of 8, and this is equal to e raised to the power of ln of 1 over 2 multiply ln of 1 over 2. Now if you take a look at this, we have that a right here, which is minus x, and e right here, which is raised to the power of a. And if you take a look at this, the value of a and the value of a right here in e raised to the power of minus x ln of 8 are the same thing. And at the right hand side, we have that a, which is ln of 1 over 2, is the same thing as a in e raised to the power of ln of 1 over 2. So these two equations correspond with the Lambert W function. So applying the Lambert W function right here to both sides of the equation, we have this to be equal to minus x ln of 8 is equal to ln of 1 over 2. So we have this right here. But we know that 8 is equal to 2 raised to the power of 3. So this becomes minus x ln of 2 raised to the power of 3 is equals to ln. Now we know that 1 over 2 can be written as 2 raised to the power of minus 1, right? So this becomes 2 raised to the power of minus 1. So applying the logarithmic property that states that ln of a raised to the power of m is the same thing as m ln of a. So applying this property right here, this becomes minus x multiply 3 ln of 2 is equals to minus 1 multiply ln of 2. So this becomes minus 3x ln of 2 is equals to minus 1 ln of 2. So we want to simply divide both sides by ln of 2. So divide both sides by ln of 2. This is going to cancel out this. We have minus 3x is equal to, this cancel out this, we have this to be minus 1. So to solve for x, we divide both sides by minus 3. So this is going to cancel out this. So we have x is equals to minus cancel minus, we have this to be 1 over 3. And this becomes the first value of x. So we are going to call this x1. So we have been able to solve for the first value of x. So in order for us to be able to solve for the second value of x, so I'm going to write this right here for the second values of x. Now we want to simply work with this. We have this to be minus x ln of 8 multiply e raised to the power of minus x ln of 8 is equals to 1 over 2 multiply ln of 1 over 2. So we want to simply work with the right hand side. So we say for the right hand side of this equation, which is 1 over 2 multiply ln of 1 over 2. The first thing we want to do right here is to multiply by 4 over 4. So we say multiply by 4 over 4. This becomes 4 over 4 multiply 1 over 2 into ln of 1 over 2. So from here, 2 here is 1, 2 here into 4 is 2. So we have this to be 2 multiply 1 is 2 over 4 ln of 1 over 2. But we can easily express 2 over 4 to be equal to 1 over 4 multiply 2. So this implies that we have the expression to be minus x ln of 8 multiply e raised to the power of minus x ln of 8 is equal to 1 over 4 multiplied to ln of 1 over 2. So we have this right here. But from the logarithmic property, we know that if we have b ln of a, this is equals to ln of a raised to the power of b. So from here, we have the right hand side of the equation to be 1 over 4, the ln of 1 over 2 all square. Okay, so this is equal to 1 over 4 ln 1 square is 1 over 4. So we have this right here. So therefore, we have that minus x ln of 8 multiply e raised to the power of minus x ln of 8 is equal to 1 over 4 ln of 1 over 4. So as you can see right here, applying the Lambert W function that says W multiply A e raised to the power of A is equals to A. Now if you take a look at this A right here, we have minus x ln of 8, and if you take a look at the power, which is A, they are all the same thing. And if you go to the right hand side right here, we have A right here, which is ln of 1 over 4. But we do not have e raised to the power of A. So in order for us to be able to have e raised to the power of A, we want to observe this property that says that e raised to the power of ln of A is equal to A. So we say e raised to the power of ln of 1 over 4 is equal to 1 over 4. So we want to simply change that right here. So hence, the equation becomes, so from applying this, the equation becomes minus x ln of 8 multiply e raised to the power of minus x ln of 8 is equal to, now in place of 1 over 4, we put e raised to the power of ln of 1 over 4 multiply ln of 1 over 4. If you look at the right hand side of this equation, you will find out that it is satisfying the Lambert W function, whereby A is given as ln of 1 over 4 and e raised to the power of A, we have it as e raised to the power of ln of 1 over 4. So right here guys, all we have to do is to simply apply the W Lambert function right here. So applying this right here, we have this to be minus x ln of 8 is equal to, so if you apply the Lambert function right here, we have this to be ln 1 over 4. So we have this right here, but we know that 8 can be expressed as 2 raised to the power of 3. So this becomes minus x ln of 2 raised to the power of 3 is equal to ln of 1 over 2 raised to the power of 2. Now we have that because 4 can be expressed as 2 raised to the power of 2. So from here, we have that minus x ln of 2 raised to the power of 3 is equal to ln of, now we can express this to be 2 raised to the power of negative 2. Because if we have 1 over a raised to the power of n, this is equals to a raised to the power of negative n. Alright, so applying this right here. So next, we want to simply apply the logarithmic property that says if we have the ln of a raised to the power of b, this is equals to b of ln of a. So applying this property, we have that 3 multiply negative x ln of 2 is equal to negative 2 multiply ln of 2. Alright, so we have this to be negative 3x ln of 2 is equals to negative 2 ln of 2. So from here, we want to divide both sides by ln of 2. So dividing both sides by ln of 2, this is going to cancel out this. So we have this to be minus 3x is equals to, this is going to cancel out this. We have this to be minus 2. So divide both sides by negative 3. So this is going to cancel out this. We have that x is equals to, minus is going to cancel out minus. So we have 2 over 3. So this becomes the second value of x, and I'm going to call this x2. So hence, we can say that the values of x, now we have the first value of x to be x is 1 is equal to, so let's simply go back right here and look for the first value of x. We have the first value of x to be 1 over 3. So this becomes x1 is 1 over 3 and x2 is equals to 2 over 3. So right here guys, this is how you can solve this question right here that says a raised to the power of x minus 6x is equals to 0.